Hello everyone, my name is Wang Bowen and I'm glad to introduce my recent work, Taming the Untamed, graph-based knowledge retrieval and reasoning for MLLMs to conquer the unknown. We explore how multimodal knowledge graphs can drive retrieval and reasoning so that multimodal large language models remains reliable even in unfamiliar scenarios. Despite impressive general performance, MMS face three main points on domain-specific tasks: knowledge gaps, hallucinations, and limited explanations. In real development, this issue directly impacts safety and reliability. We therefore integrate structured knowledge with domain rules via knowledge graphs, so models have grounded evidence even in unfamiliar environment. Traditional vector-based multimodal RAG exist at similar search but struggle to represent causal and conditional structure. We introduce MMKG-based MRAG, a graph backbone with multimodal attributions. Retrieval is no longer only about look similar but about following valid logical chain. Different to pure text knowledge graph, multimodal knowledge graph will incorporate images and other things as attributions, which is more knowledge rich. Our works makes two main contributions. We built MLLM MMKG and MLLM benchmark that covers uncommon scenarios, combine video, keyframe, text attributions, achievement conditions, and diverse age types. We also propose a training-free multi-agent graph retrieval pipeline that is model agnostic, enables self-directed reasoning with interpretable chains. We use Monster Hunter gameplay videos as a testbed, 4K 16 FPS recording with complex player processing. MLLM benchmark contains 238 QA instances paired with MLLM MMKG, which encodes task rules, achievement conditions, and interaction relations. This design supports robust evaluation of retrieval and reasoning. MLLM MMKG contains 22 subgraphs, and each subgraph is for a specific monster, and there are totally 7 node types and 158 edge types. Nodes carries text, images, videos, and keyframes, each encode entity relations and achievement conditions. During retrieval, the model can trace semantic conditions, outcomes, chains, but not just surface similarity. Firstly, we want to confirm the visual capability of existing multimodal large language models like GPT-4 to recognize image from monster hunters. And we take Xenogirl as a sample. For this image, the important part is to find the widely open mouth, and we find GPT-4 has such kind of ability. We also want to confirm their ability for recognizing video and input continuous video frame into the GPT-4o. We find GPT-4 can find some video element but cannot recognize a key point like the right claw sweep across the ground in a wide arc generate a surge of lightning along its path, so we find the video ability is one limitation. We have 6 experimental settings. First, Vanilla relies only on model's own variability without any additional knowledge. And as a comparison, Vanilla Plus, we use human description instead of model's own variability. And knowledgeable with human description and given graph passes towards the ground truth. And perceptive, we giving the human right description and let the model to search relevant knowledge by itself. And unlaid offline is depend on model's own viewability, but it will pre-generated all captions for visual medias. And only the online, it's online perception plus retrieval. It rely on model's own ability to retrieve the knowledge from multimodal knowledge graph. We also designed a multi-agent retriever to retrieve the relevant knowledge automatically. There are totally 5 agents. First, perceiver will convert the input query into a pure text description, and based on this, topic selection will select the most relevant node as the start point for the retrieval, and then validation agent will validate whether knowledge up to current nodes is sufficient to answer the query. If not, the expansion agent will try to find the most relevant next neighborhood node for retrieval, and the validation and expansion agent will iteratively to find the relevant knowledge. When Validation agents say the knowledge is sufficient, and all find root will be converted to a pure text knowledge and as an augment to the summarizer agent to answer the question. Experiments show visual insufficiency drops performance, but knowledge insufficiency is even more damaging. Many models perform better in text-centric settings, suggesting that structuring visual context into semantics, aligning it with the graph, is crucial for robustness. We find all models have good performance in perceptive settings. It means models have the ability to retrieve knowledge during a pure text environment. Some models achieve stronger results with online visual analysis coupled with. Here are some retrieval augmented examples. Models have to understand both the visual clue and the knowledge graph to retrieve the correct knowledge. For example, in the right part, model have to understand the monster is stick on the wall and compare to the knowledge graph some conditions to retrieve the both to correct knowledge. We also compare the performance of different models on only online setting. We find GPT-4o tends to search in a broader scope and will cause lower precision and higher recall. And also find the cloud is more cautious for its knowledge retrieval. Here we show the advantage of online settings. We can find all online settings will giving a higher value of similarity. It means model tend to generate accurate visual description. Here are some application studies. We can find that GPT and cloud perform best when using top 5 retrieval knowledge, and the BFS is the best strategy for knowledge retrieval. Here we show some prompt settings for the perceiver agent and validation agent. We have to point out models are sensitive to prompt settings. This is all my presentation. Thanks for listening, and the left corner is a QR code for this project.